Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of unit vector. So unit vector are special vectors, and why is it special is because these vectors have length equal to 1, which means that the magnitude here is equal to 1, and it points in the directions of either positive x, positive y, or positive z. So the first unit vector that I'm going to talk about is vector I. So vector I here has a component 1, 0 and 0. So these are examples of, these three here are examples of three-dimensional vectors. Now if you want, you can check that this magnitude will be equal to 1. So we know that magnitude of a vector can be found by taking the square root of the first component, you square it, plus second component, you square it, and the third component. So this will result in getting the answer is 1 plus 0 plus 0, which is 1, and square root of 1 is 1. So therefore the magnitude here is 1. To represent it in the graph, it is very simple. You can first start sketching the axis. You have three axes, x, y and z. So for this one, you can think about it as having only the x component, so 1 unit. So this is the vector I. This is 1. Okay, so 1 0 0. Now for vector j, you only have component y, so it's going in the positive direction because the value here is positive, so it's going upward, okay, as shown in this figure here. So this is component j, this is at 1, length 1, so 0 1 and 0. And finally you have this vector here, vector k, where it has component 0 0 and 1. So this is in the z direction, so 1 unit up, so okay, 1 unit to the right, so 0 0 and 1. And you can check that all these two vectors here will also have the same length, which is equal to 1. Now can you come up with vectors in 2 dimensions, unit vectors I and j in 2 dimensions? Well, in 2 dimensions, clearly you will only have 2 components. So if you talk about vector I, so vector I is positive in the x direction, so that means the vector will have component 1 and 0. Okay, next if you have j is the vector that also has 2 components, and it will be positive in the y direction, so we have 0 and 1. So how do we represent this on the graph? So if I have the graph, so this is y-axis and this is x-axis, so this is 1 and this is 1, and therefore the unit vector can be sketched as follows. So this one is the first vector, so this is vector I, okay, in this positive x direction. Next we have vector j in the positive y direction, so this is vector j, so this is in the positive y direction. Okay, right. Now using the definition of unit vectors, which you have seen in the previous slide, it is sometimes preferable for any vector to be expressed in terms of I, j and k. So we call this standard basis vectors. So as an example, we have this vector here, which can be written simply as I minus 2j plus 6k. So the reason why this is I is because 1 times I, so this is 1 and I, and then negative 2j for component for j, and 6 here with vector k. Okay, so in order to see what's going on here, perhaps we can start dissecting what's going on in this part that we have here. So I here is actually a vector with component 1, 0 and 0. Okay, so this is for I minus 2 times with j. J is a component. J has a component of 0, 1, 0 plus 6 times k. K has component 0, 0, 1. So next what we can do is we can complete the process here. So we have 1, 0, 0. So negative 2, this is a scalar. So you multiply it with a vector. You will get plus negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 0 is 0. And then you will get 0, 0 and 6. Now you have 3 different vectors and you can add them all up according to its respective components. So 1 plus 0 plus 0, you will get 1. 0 plus negative 2 plus 0, you will get negative 2. 0 plus 0 plus 6, you will get 6. So there you go. You are able to show that when you are writing it in the form of I, j and k, based in this form of standard basis vectors, then you will be able to express it in this term as well. Okay, so it is important that you know how to switch between the form, either this one or this one. Now as an example, as a simple example here, let's consider these two vectors. This is vector A and this is vector B, and we're going to express 2a plus 5b in terms of I, j and k. Alright, so now 2a plus 5b, so this is equal to 2 times vector A is vector I plus 2j minus 3k. This is vector I plus 5 times vector B is 4i plus 7k. So now this becomes 2i plus 4j minus 6k plus 20i plus 35k. Next, we're going to add up according to component vector I, j and k. So 2 plus 20 will be 20i. Next, 4j, so there is no j here on this part, so it will just remain as 4j. Next, negative 6k plus 35, now that would be equal to 29k. So this is the answer. And if let's say you want to write it in the form, in the previous form, you can, but since the answer is asking you to write it in terms of I, j and k, then this is the answer. But the same form, its counterpart would be you can write down this vector also as 24 and 29. So this is a similar representation to the standard basis vectors I, j and k. Alright, next. Now given any vector v where v is not equal to 0, then you can actually find a unit vector. Now what is a unit vector? Again, a unit vector means it is a vector that has magnitude equal to 1. And you can find this unit vector that has the same direction as v, and the way you can find it is by using the formula given in this box here. So as an example, suppose that this is a vector given by 2i minus j minus 2k. So first of all, in order to find a unit vector in the same direction of this vector, you can start by finding its magnitude. Okay, so we can find the magnitude of 2i minus j minus 2k, and then this will be equal to 2 squared plus negative 1 squared plus negative 2 squared, and this becomes 4 plus 1 plus 4, and this is just 9, so square root of 9 is equal to 3. So therefore vector u is equal to vector v, so 2i minus vector j minus 2k over the magnitude of that vector. The magnitude of the vector is 3, so over 3. And that can be reduced or can be simplified to 2 over 3 of vector I minus 1 over 3 vector j minus 2 over 3 vector k. So this is the answer, and of course you can go on and check whether this is the correct answer by finding what's the magnitude of vector u. So the magnitude of vector u will be 2 over 3 squared plus negative 1 over 3 squared plus negative 2 over 3 squared. And this can be simplified as 4 over 9 plus 1 over 9 plus 4 over 9, and the answer is equal to 1. So therefore vector u here is the unit vector, and we can be certain that the answer that we got here is correct. Okay, so this is just for a checking process, so this is for checking. All right, if you want to change the form of this vector to the standard form, okay, to the other form, so what we can do is we can also say that u is a vector 2 over 3, negative 1 over 3, and negative 2 over 3. Okay, all right, that's all for now. Thank you very much for watching, and I'll see you in the next video.